Good morning. I welcome you all to the series of lectures on thermodynamics. Today we will solve problems on reversible heat engines. A reversible heat engine receives heat from high temperature reservoir at T1 Kelvin and rejects heat to a low temperature reservoir or sink at 800 Kelvin. The second reversible heat engine receives the heat and rejects to a cold reservoir at 280 Kelvin. Find temperature T1 for equal thermal efficiency of two engines, and for second one is for the engines deliver the same amount of work output. So that means we need to calculate the T1 temperature for equal thermal efficiency. If both engines perform the same thermal efficiency, what is the temperature T1? If both the engines deliver same work output, then what is the temperature T1? Here temperature T1 from which heat is Q1 is taking, and this is the engine E1, and it delivers W1 amount of work and rejects part of heat, that is Q1. That is part of heat is converted as W1 and remaining part of Q1 is rejected as heat, that is Q2, to the low temperature reservoir T2. And the second engine is connected such that this heat is taken by the second engine, same Q2, and it converts part of Q2 to W2, that is work, and the remaining part of Q2 is as rejected as Q3 to the low temperature reservoir T3. Okay, now T1, T2, T3. So engine 1 is operating between T1 and T2. Engine 2 is operating between T2 and T3. T1 is more than T2. T2 is more than T3. W1 is Q1 minus Q2. W2 is Q2 minus Q3. For example, let us consider the first situation for equal thermal efficiency of two engines. That is neta 1 equal to neta 2. Efficiency of engine 1 is equal to efficiency of engine 2. Then efficiency, both the engines are reversible engines, so efficiency of engine 1 is the function of T1 and T2. So T1 minus T2 by T1, that is the formula for efficiency of engine 1. For efficiency of engine 2, T2 minus T3 by T2. So you know all the values. T2 you know, T3 value has given 280. So you don't know T1 value, you can get from this T1 value as 2285 Kelvin. And if both the engines deliver same work output, that means W1 is equal to W2. W1 already you know, Q1 minus Q2, which is equal to W2, that is Q2 minus Q3. If you divide with Q2, Q1 by Q2 minus 1 is equal to, this is Q2 by Q2 means 1 minus Q3 by Q2. These engines are reversible engines, so you can write Q1 by Q2 as T1 by T2, Q3 by Q2 as Q3 by Q2 as T3 by T2, corresponding temperatures. Not Q1 is not equal to T1, but the ratio of heat interactions is equal to the ratio of corresponding temperatures. So T1 by T2 already 800 has given is equal to, sorry, minus 1 is equal to 1 minus T3 280 by T2 is 800. So from this you can get T1 as 1320 Kelvin. If both the engines deliver same work output, the highest temperature is 1320. If both the engines deliver same work output, the highest temperature is 2285 Kelvin. Now let us switch over to the next problem. Two Carnot heat engines C1 and C2 working in series between two reservoirs at 1000 degrees centigrade and 37 degrees centigrade. The heat received by engine C1 from 1000 degrees centigrade source is 5 megajoules. That is Q1 has given as 5 megajoules. And the efficiency of engine C1 is 1.25 times that of efficiency of engine 2. That is efficiency of 1 is 1.25 times the efficiency of engine 2. Estimate the work output from the engine C1 and C2. That means W1 and W2 we need to calculate. This statement is efficiency 1 equal to 1.25 times the efficiency 2. Efficiency 1 is T1 minus T2 by T1 is equal to 1.25 times efficiency of engine 2 is T2 minus T3 by T2. Now, if you substitute the values of temperatures here and there, you will get the intermediate temperature. You know T1 and T3, intermediate temperature you don't know. So from this logic you can calculate, because in this situation, in this equation, you know every temperature except T2. So from this T2 can be calculated, that is 561 Kelvin. So both the engines are reversible, that is Carnot engine. So Q1 by Q2 equal to T1 by T2. So from this T1 value, T2 you know, Q1 value you know, you don't know Q2, that you will get. So see, Q1 is 5 megajoules, by Q2 you don't know, T1 T2 know, so Q2 you will get, this is megajoules, so you will get Q2 also in megajoules, 2.2 megajoules. Q2 by Q3 is equal to T2 by T3. Q2 already you know 2.2, by Q3 you don't know, is equal to T2 561 by T3 is 310. So you will get Q3 as 1.21 megajoules. So W1 is nothing but Q1 minus Q2. So from this you will get 2.8 megajoules, that is 2.8 megajoules as W1. And W2 is Q2 minus Q3, you know Q2 and Q3, from this you will get 0.99 megajoules, that is W2 equal to 0.99 megajoules. Now let us go to the next problem. A reversible heat engine receives heat from two thermal reservoirs at 870 Kelvin and 580 Kelvin. This is the reversible engine. It receives the heat from two thermal reservoirs. What is? One is at 870 Kelvin and another one is at 580 Kelvin. Let us T1 and T2. So Q1 amount of heat is taken from T1, Q2 amount of heat is taken from T2. So now heat supplied to the engine is Q, that is Q1 plus Q2. Heat supplied to the engine is Q1 plus Q2. And rejects 550 kilowatt of heat to a sink at 290 Kelvin. It rejects, this engine rejects 50 kilowatt of heat, that is Q3, to low temperature reservoir, that is at 290 Kelvin. This is T1, T2, so it is T3 equal to 290 Kelvin. Make calculations for the engine efficiency and heat supplied by each reservoir. So we need to calculate the engine efficiency and Q1, Q2, Q3 values. Q1 and Q2 values only, because estimate the engine efficiency and heat supplied by each reservoir. Heat supplied means Q1 and Q2 only we have to calculate. In that process automatically you will know, because Q3 already has given, that is 50 kilowatt. Now neta you need to calculate Q1 and Q2, you need to calculate. W he has given, work output is 85 kilowatt, heat rejected Q3 is 50 kilowatt. Now cyclic integral of work transfer equal to cyclic integral of heat transfer. This is the first law of thermodynamics. And you know W net equal to, the net is equal to heat supplied minus heat rejected. Heat supplied is Q minus heat rejected is Q3. So W net equal to, he has given 85 is equal to, Q means Q1 plus Q2 minus Q3. So 85 equal to Q1 plus Q2 minus Q3 is 50, minus 50. So from this Q1 plus Q2 equal to 135 kilowatt. From Clausius inequality, cyclic integral of delta Q by T is less than or equal to 0. Cyclic integral of delta Q by T is less than or equal to 0. So cyclic integral of delta Q by T is equal to 0. It is reversible heat engine. This is Clausius inequality. From this equal symbol come, because it is a reversible heat engine. So for reversible heat engine, delta Q by T equal to 0. So delta Q by T means heat interactions with respect to corresponding temperatures. Sum of all the heat interactions with respect to temperatures must be equal to 0. So delta Q by T means, cyclic integral of delta Q by T means, so Q1 by corresponding temperature T1 plus Q2 by corresponding temperature T2, because these two parameters are positive because heat supplied to the system, whereas Q3 is negative because heat is rejecting from the system. So minus Q3 by corresponding temperature is T3 equal to 0. So from this you will get Q1 by T1 you know, plus Q2 by T2 you know, minus Q3, that is 50 by T3 also you know, is equal to 0. So from this you will get one relation in terms of Q1 and Q2. So if you solve this one, you will get relation in terms of Q1 plus Q2 equal to some value. Let it be equation number 2. If you observe 1 and 2, you know, here also Q1 plus Q2, here also Q1 plus Q2 is there. By doing some exercise here, you will get from equation 1 and 2, you will get Q1 value as 105 kilowatt and Q2 as 29.28 kilowatt. It is a simple calculation. Upon doing some simple calculation, you will get Q1 and Q2 values. And the efficiency equal to net work done by heat supplied. Net work done he has given, it is 85. Heat supplied to the system means, heat supplied to the system means it is Q1 and Q2. It is not one value, because both the reservoirs are supplying heat to the engine. So heat supplied to the engine is Q1 plus Q2. So 85, W net is 85, Q1 plus Q2 is equal to 135. Even if you add these two, you will get 135 only. Okay. Now 85 by 135 means it is 62.9%. Thank you very much.